Alright, everybody, let's begin.
My name is Mr.
I'm
Auerbach.
Mr. Auerbach. I'll be your biology teacher today. I'm sorry?
You're not in the camera.
That's
It's
okay.
Like half of you.
Now I'm in the camera. That's okay. I don't need to be in the camera. I need my knowledge to be in the camera here. Okay, so what we're talking about today, we're talking about atoms.
Atoms.
Now,
Like the Ernie paper.
we already talked about what atoms are. They're the smallest unit of matter that has properties of that type of matter, so forth and so on. What we're going to do is we're going to get inside the atom a little bit. So if I was going to draw an atom, what do I draw?
A circle.
I'll be like Mr. Noodle here. You guys remember Mr. Noodle?
Who's that? What's
You
that?
remember Mr. Noodle from Sesame Street? You tell him what to do and he does it?
No.
Oh, you draw a circle.
Like little spiral things going around with little dots on them.
Alright,
Yeah.
so, yeah.
Don't you draw like three of them? A
Three
big
what?
one, another one inside, and then a small one.
No, you're wrong.
So I'll start with the small one,
Let's target.
and then another one, and then another one.
It's like a
that
triple
kinda.
layered donut.
I know what you're talking about too. You're talking about something that's like all like that, and I can't draw that, so I'm not going to draw that. But yeah, that's another way to draw an atom. But okay, for right now, let's
That looks
draw.
like a multi.
Let's draw that. In
layered
fact,
donut.
let's just leave one little ring on the outside for now, before we get too complicated with all this.
How big?
Let's say we got the two main parts of the atom here. So if I was
You
going
want
to
us to draw
start,
that?
How big should we draw it?
I don't know. I would say on your notes, maybe like about
This
that big,
size?
something like that.
That too small?
That'll do it. Yeah,
Baseball? Let's see, Ethan.
about the size of a baseball. Sure. All right. And so what do I got here? I got two different parts here. What do we got here?
Circle.
You got your
Little circle. You got your big circle and your little circle. Nucleus. Okay. Let's start with the. We'll say the red part here. We'll call that the nucleus.
We don't have red.
Well, you're just going to have to draw an arrow. I did tell you guys to get yourself a set of colored pencils so that you could
You
mimic
think I'm
the brilliance you see up here. All right, so you
My
got the
family's
nucleus, and then what do we got? What do we got out here? Anybody?
Electrons?
The outer
Electrons? Is
layer.
that what you said?
Something
Yep.
like that.
Okay, we're going to say electrons. Yeah,
Not what I
and
said.
I'll make this. That's all right. Might not be what you said, but that's what you should write. We'll say that out here is our electrons.
I did this last year.
Good. Yeah,
Yeah,
you probably did. This is
There's
kind
like
of a
6
review
points.
from IPS. So you got your electrons out here. I'll draw them. Actually, you know what? I'm going to keep the circle black. And aren't you glad you're not using colored pencils? You guys would be mad at me now for changing like 3 times. But I'll make the electrons.
We did this last year. It's easy.
Good. Okay, so you got your electrons on the outside. You got your nucleus on the inside. The nucleus is the center, right? That's always, you hear that in a lot of contexts, but the nucleus is always the center. And it turns out the atom is a lot bigger than the nucleus. The atom's mostly empty space. I think that if the nucleus, to give you a proportion, if the nucleus was the size of a golf ball,
Same
like just to
size.
give relative size,
That's about the size of that. Like
the
that.
nucleus was the size of a golf ball or that bottle cap, then the electrons would be about over in the harmony lot. Just to give you some idea of like the relative
It'd
proportion.
be
So
what?
what's that? About 2 miles away. So relative to the size of a golf ball.
Maybe 2 miles.
Yeah, something like that. So, and here's another one. If the nucleus was the size of a period at the end of a sentence, then the electrons would be, and you put that period in the center of a football field, the electrons would be in the end zone. So like, seriously, the atom is mostly empty, and the nucleus is the very dense middle. And then you've got these electrons, which are just tiny, barely there little things that are flying around the outside. And so, all right. So the nucleus, though, there's a couple different things that live inside the nucleus. Anybody remember what they are? What lives inside the nucleus? Protons, said somebody. Yep. Okay. We'll make protons blue.
Where do those go?
A few of those. Let's do 3 of those. And what else lives in there? Anybody remember? There's one other thing.
Oh,
Neutrons, says somebody who is absolutely right. Neutrons. We'll put those in here. All right. Okay, so let's stop for a second. We'll write down what we got here. We've got your protons.
I probably have these notes from last year still.
Probably. And you've got your neutrons. And they live inside the nucleus.
Can I just put an arrow pointing to that? Like proton.
Sure, whatever you like. That's what I'm going to do. Here's your proton. Here's your
Oh, I'm so
neutron.
tired.
All right, so what does this kind of remind you of? You got this dense part in the center, and you got stuff going around it.
An atom.
Well, yeah, it is an atom actually, but a lot of people say it's kind of like the solar system. You got the let's move to orange here. You got the sun in the middle.
Supposed to be drawing this?
Yeah, actually you should. So here you
Well, I can't see. You're in my way.
well, I'll be done in a second. Here's the sun, and you got.
Sorry, Mike, I'm pretty sure that was a highlighter.
It was. I know. That's all right. I'll use my spray to get it out. You got the sun going around it, and you got your planets here. Here we are, third stone from the sun, as Jimi Hendrix said. And these are going. Did you just say who the hell's Jimi Hendrix?
Yeah.
What?
You know,
I can't smack you because we're on camera, but man,
But man.
Jimi Hendrix, greatest guitar player to ever live, greatest rock and roll guitar player to ever
You
live.
I
wouldn't
don't
be
know
on
who he is
camera.
either.
What's that?
You wouldn't actually be on camera.
That's true. All right, excuse me.
Punch him in the nose. I'm just like, you
I'm
know.
kidding. All right, but okay, so you got planets going around the sun.
face!
You got electrons going around the atom, right? So that's a pretty good analogy. It's a good model, but what's different? One thing? What is it that's keeping the planets from flying off into space? Gravity, right? Yeah.
Oh, really?
So all the planets are attracted towards the sun because the sun is huge. Actually, the sun is much larger than the rest of the planets. But anyway, the gravity of the sun is drawing all the planets in. They keep moving because they've got speed going this way. I suppose if you took a planet and just made it stop, at that point it would just fall into the sun.
Eventually.
Right, well, that's true. Problem. Superman did it. He made the Earth change direction. Superman movie. But anyway, let's move on back to the real science. So gravity is what's keeping the planets from flying off. What is it that's keeping the electrons from just flying off? Because they're moving even faster than the planets. It's not gravity actually. It's something else that's keeping the atom together. Does anybody remember what it was? This was something you learned in IPS if you took IPS here. So they're moving. What is it that's keeping these from just flying off into space?
Gravity.
Not gravity. Something else.
Pull. Something pull.
Some sort of pull, yeah. Something's
Gravity.
pulling on. Okay, give you a hint. Now, this is not a very good hint, but there's 4 major forces in the universe that hold stuff together. And
Magnetic.
one of them, whoa, yeah, right. Yeah, exactly. One of them's gravity. The other one's electromagnetism. So actually, we're going to say it's not really magnetism.
dumb as I look.
It's electricity.
Want to get punched? Whoever said that?
Yeah.
What he's saying is you don't look dumb at all.
Exactly. Jesus.
Who is that talking back there? Oh, of course, it's Dylan. Dumb.
All right. Electricity is what's holding these together, and electricity really comes down to 2 things. Positive,
I put my finger in one of those outlet
Negative.
sockets.
positive, and
You're
negative.
real smart.
I'm going to erase the word electrons here because I got to draw something else. Positive and negative. And so, what do positive and negative do to each other? How do they interact? Like, positive and negative. You got your car battery. You got the red
Put
and
the
the black
ground.
cable.
Put the positive
They
on
separate.
the terminal,
Well, I'm not asking you how
and
to
then
jump
put the
start.
ground on your tongue.
Ooh.
Do it. I
Don't
dare
they
you.
make them stick together because the negative and push pushing away or positive?
He's a
Positive and negative attract each other, actually. Just like
Yeah, because if you take jump
just
tables,
like a
put one
magnet.
positive, one negative, and you go like this,
Positive and
and it goes
positive
zit,
would
zit,
stick.
and then the wall will
right, positive and positive.
Sorry.
If we had positive and positive,
Seen it happen.
they are gonna repel each other.
Yeah, well done.
And actually, if we had negative and negative, they're also gonna push each other away, like magnets. You got
You know, if you take a
Here's-
jumper cable and you put one to the positive, one to the negative, and you hold the two and you go like this, you can stick them together.
I know that well. In fact, if you lay a wrench across your two, accidentally lay a wrench. That's why you're never supposed to put a wrench down on the inside of your hood. Is if you lay a wrench across the two terminals, it'll weld itself right there, and you'll
Got
blow
yourself
up
a
the battery. Anyway, so I got two magnets here. The red is positive, the blue is negative, and if I put them together, they'll stick. And if I take the positive and try to put them together, they kind of, as they get closer, I can feel the pressure build up, and they kind of veer
no,
off.
you can't.
You can.
I don't know.
Hey, Ken.
Probably can.
Here, I'll show you.
No, you can't. Oh, yes, you can.
Look at this. Now these are really strong magnets. These are neodymium magnets. That's actually, if you look, they're what's holding my periodic table up onto the
It's
cage
doing
up
this on
there.
its own.
So like, all right. And so if I take them and put positive and negative together, they'll stick to each other. But wait, wrong way. If I turn it around and I got the positive and the positive side facing each other, they're going to repel each other. So that's sort of like this: positive and positive, negative and negative. They repel each other. But if you turn it the other way, they attract.
Let me try that.
Go ahead.
That's pretty sweet.
Oh, it broke. Just like gravity's holding the atom or the solar system together, electromagnetic force is holding the atom together because the electrons and the protons have a charge. Does anybody remember which is which? Which one has the positive charge? Protons have the positive charge. And I'm going to draw little pluses inside my 3 protons. And I'm going to draw little negative signs next to all my electrons.
You're a smart cookie, ain't
What
you?
are neutrons?
Well, what about neutrons? What charge do neutrons have?
Nothing.
They don't have any charge, and so actually that's why we call them neutral. And it's an easy way to remember which is which. And I'll show you in a second. Neutral meaning no charge. The neutrons are just there to hold the protons apart. Because if you think about it, these should all repel each other. The protons and the protons, but they don't. One of the reasons is that the neutrons hold them at just the right distance. There's a lot more to it than that, but that's what I'll say. No, gotta
I
wait.
gotta pee.
You gotta wait. You can wait.
Alright, can I?
You can wait.
I'm gonna piss in the trash.
Okay, I'll take that chance that you can wait 2 minutes.
Come on.
2 minutes.
You're 2 minutes like an hour.
Yeah, sometimes. Not today. Here's the thing, folks. Here's how you remember. Protons are positive. P for proton. Sorry, Ethan. P for positive. Last thing I'll say. This is the way you remember it. P for positive helps you remember that the protons are positive.
P for positive.
You're gonna piss.
And then neutrons are neutral. Look, the word's right in there. N-E-U-T-R is the root. N-E-U-T-R for neutral. Right? P for positive, neut for neutral. And then by process of elimination, one of them's got to be negative, and that's the electrons because they're left over. So that's what's holding it all together. Alright? Okay. Take a minute, get that all down.
Positive.
I asked, what's wrong with this picture? And Ethan correctly told me there are more negatives than there are positives.
Yeah.
In any atom, you always have the same number of protons as electrons. So let's get rid of one of these. There's actually something else wrong with this picture, but I'll ask
I
about
don't have
that
an
later.
eraser.
What's that?
I don't have an eraser.
Well, that's okay. That's all right. But just
That's
Are we
okay.
supposed to redraw it?
no, I don't think you have to redraw it. That's just my lead into the next thing. It turns out you always have the same number of protons as electrons. And the other thing is that all the different elements on the periodic table, now people at home, you don't see this, but over here is my periodic table. And if you look in the upper right hand corner, everything has a number. Like hydrogen's number 1, helium's number 2,
And Ethan's number 3.
lithium's number 3. It turns out that the periodic table arranges things by what's called the atomic number, which is the number of protons. So this is lithium because it's got 3 protons, atomic number 3. And when you have 3 protons, you're going to have 3 electrons. And that goes all the way up through the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Hey,
It's neon.
lasers are illegal at school.
And then, not for me. And then all the way up to number 114, ununquadium. Actually, ununoctium has now been discovered too. Number 118. That has 118 protons. And so they get bigger as you go through the table.
You're a smart one.
And here's the thing. The one more thing I have to teach you guys, and it's okay, folks. So here's the thing. The other thing that's wrong with this picture is you can't really fit 3 electrons in the first level. So if this was lithium with 3 protons, I'm just going to write 3p plus, guys. When we start putting, so this is the nucleus again. I put 3p plus to mean 3 protons. When we start putting stuff around the nucleus, turns out that there's only so much room for electrons in each level. Once you get 2 in here, turns out that's the number of electrons that can fit in that first level because it's kind of small. It's right near the nucleus, and if you had any more, there'd be too many in there. And so when we put the next one in, we have to go up a level. And you can call these energy levels, you can call them orbitals, there's a lot of different names for them. You can call them shells, but we would put that third one up there. And as atoms get bigger, I swear to God, this is the last thing, as atoms get bigger, so, you know, if I had number 4, then we'd add another one in here, all the way up to number 10, that would fill in with 8 total. Where am I at? How many is that? 1, 2, 3, 4, 5, 6, 7. Is that really 8? 2, 3, 4,
That's 8.
7, 8. Alright, well, they're not quite evenly spaced, but that's 8. And then it turns out that that's as many as can fit in that level. And the last one we're going to do in this class
It's 16.
is the third one. Well, it does hold, that was really close. It holds 18. But for our purpose, we're just going to say it holds 8. Because the other 10, they kind of go in a secret pocket that you don't learn about until chemistry. So we're just going to say, for right now, that the levels go like this. Level 1, oh!
Timber!
Level 1 holds 2 electrons. Level 2 holds 8 electrons. And level 3 also holds 8 electrons. Though, as Ethan said, there are more than that, but that's alright. So what we're going to practice tomorrow is filling in the proper number of electrons around any particular atom, and that's what we're going to do tomorrow. Thank you very much for your attention. I'm Mr. Auerbach, and you can press stop.
Which button's that?
The big red one.